Show that the square root of 2 minus 1 over 2 is less than the integral from 0 to pi over 4 of sine x over root 1 plus cos squared x dx is less than square root of 2 minus 1 divided by square root of 3. Okay. So my first instinct here is that we're probably not going to be able to integrate completely the whatever we're given here, although maybe I'm wrong. We'll probably use some trig identities to manipulate the integrand and then bound, just basically put bounds on the integrand. And maybe what we'll do is like we'll transform the integrand into something we can integrate along with, and those transformations may not be exact, right? We might I might write down another function which is strictly greater than the function we have here, but it's something that I can integrate. And hopefully we end up with the thing on the right-hand side and do something similar for the left-hand side. I'm not totally positive though. You know, anytime we're given an inequality, there could be a whole bunch of different ways to do it. But I'm going to start by writing down the original integral here. And this question might just involve a whole bunch of guessing and checking. So one thing I'm thinking of, the denominator does not look exactly like a Pythagorean substitution we could make. But if I factor, oh wait, no, hold on. No, that doesn't work. I mean, I'm going to write down briefly some of the Pythagorean substitutions we can make here. If I divide by sine squared, well, no, let's divide by cos squared. So we have tan squared plus 1 is equal to, what's 1 over cosine is secant. I don't think that's going to work in any way. Okay, I'm going to start. I don't know if this is the right way to go, but I'm going to start by noting that because we're integrating between 0 and pi over 4, this whole thing is, of course, always greater than 1. If that's greater than 1, then this whole thing is less than sine x. And we might be able to do better than that based on the minimum and maximum value of cosine squared in this interval. But let's just continue with this for now to see what comes out of it. And this is equal to negative cosine of x evaluated 0 and pi over 4. So I have negative cosine of pi over 4 plus 1 cosine pi over 4 is 1 over root 2, right? Let me just make sure of that. Pi over 2, pi over 4 is 45 degrees. Yeah. So cosine of pi over 4 is 1 over root 2. So this is 1 minus 1 over root 2, which is equal to root 2 minus 1 over root 2, which is not exactly what we're asked for. The The less than inequality is a root 2 minus 1 over root 3. Right? If I make this bigger, the whole thing gets smaller, so I can't just substitute that. So this doesn't quite get us there. So what I've done is I've replaced this with something smaller, and therefore the whole thing gets bigger. Another way to possibly approach this, it'll probably be worse. I think this will be worse, a worse estimate. If I compute the maximum value of this and then multiply by pi over 4, we would get the correct inequality. But I don't think that's a good approach. Certainly if we take the maximum value of this and multiply by pi over 4, well, we're going to have something like a pi over 4 down there. So unless the maximum of this has a 1 over pi in it, I don't see that working. So we need to come up with a better estimate. A better, like a sharper inequality, basically. Let's start again. 0 to pi over 4. Oh, yeah, I see what we could do. Oh my goodness. Okay, so let's look at the graph of 1 plus cosine. So cosine looks something like that. If I find the minimum value of this on this interval, then that will give me a maximum value of the reciprocal. So the maximum value of 1 over that. Okay. So the way I want to do this, cosine x, this is pi over 4, then on, so for x between 0 and pi over 4, I have cosine x is greater than or equal to cosine of pi over 4. And so cosine squared x greater than or equal to cosine squared of pi over 4. You can add 1 to both sides, 1 plus that, 1 plus that, and take square roots. So if I replace the denominator with this, then the denominator gets smaller, which means the whole thing gets bigger. So then I have the integral sine x divided by 1 plus cosine squared x dx will be less than, and it's a strict inequality because I mean this is an equality only when x is equal to pi over 4, and for the rest of the interval it's a strict inequality. So it does become a strict inequality here. 0 pi over 4 sine x divided by cosine squared of pi over 4 plus 1 square root dx. And this is equal to, well, cosine of pi over 4 we just said is 1 over root 2. So this is 1 over 2 plus 1 under a square root We have sine x in the numerator dx. Okay. 0 to pi over 4 sine x dx. And what is this thing in the denominator? 1 divided by root 3 over 2, so root 2 over 3. Okay. I think we're done, actually, because this integral we did already in our first attempt. Yeah, this integral from 0 to pi over 4 of sine x dx is equal to that, root 2 minus 1 over root 2. So I'll replace the integral with root 2 minus 1 over root 2, and we end up with what we're asked. So if you just follow this chain of starting with this inequality and then follow the rest are equalities, we end up with that. And so we're happy. And for the other inequality, I think we're going to do something very similar, except if I replace, so 1 plus cosine squared x is going to be, if I replace this with its minimum value, less than or equal to 2, with equality only when x is equal to 0. So I can put some square roots around that. So this tells us that the integral from 0 to pi over 4 sine x divided by 1 plus cos squared x root dx. If I make the denominator bigger, if I replace this with something bigger, the whole thing gets smaller. So the whole thing gets smaller if I do this. Right? And that is equal to 1 over root 2 times this integral that we've done a couple of times now, which is root 2 minus 1 over root 2, which of course gives us what we want. Yeah. So if we put together this thing is less than the integral, and that thing is less than this, we get both inequalities that we're asked for. I'll write it out here in full so you can see it. Yeah, so this didn't turn out to be as difficult as I thought maybe it would have been. We didn't actually need to integrate anything other than sine x. We didn't need to use any fancy trig substitutions or trig identities. Really just a question of, and it was a little bit of a stab in the dark, right? Like, I didn't know for sure that this approach would work from the outset, but the key here, I suppose, was just putting bounds on the denominator based on the interval of integration, and then understanding how, if you minimize that, then you maximize the whole thing, understanding how those inequalities work. There might be other ways of doing this, and in fact, here's another way of doing this. If you can actually evaluate that integral, figure out what the exact number is, and then just show that that number is in between those two, it's another way of doing this. Or maybe you have some clever manipulations of this whole thing to get an even better inequality. So maybe there's a number larger than this one, which is still less than this. I mean, that would then also prove that this is true. But I'm sure, based on the source of this question, that this is what was intended to be done. It's a nice question. It takes a little bit of thinking and not just thinking, but also trial and error, just experimenting and seeing where things go. And I like to have questions where that is the case, especially on this channel. Kind of demonstrates that sometimes you need to just try things before you can come to the right answer. Thanks for the submission, and thanks for watching.